Welcome back to this lecture on strong induction. In this segment, we're going to see our first proof by strong induction. And in fact, we're going to prove the same theorem as before. So in this case, remember that A is equal to 8. So the basis step will be to prove that P of 8 is true. And that's still the case for the same reason as in the previous proof. Now, let's turn our attention to the inductive step. Remember, that's where you write a direct proof of P of k implies P of k plus 1, where k is an arbitrary integer greater than or equal to 8. Well, actually, we did that proof before, remember. The difficulty there is that inside that direct proof, we had to do a proof by cases, considering whether these kind of stamps were used or not. That was a little bit complicated. So what we're going to do here is to provide a different proof of the same theorem, and we're going to reason a little bit differently. Notice we are allowed to use 3-cent stamps and 5-cent stamps. So every time you're able to form any amount, n, just by adding a 1 3-cent stamp, you should be able to form an amount of n plus 3. So what that means is that if you go 3 cents backward, you can prove the current value. In other words, here, instead of assuming just P of k, maybe we can assume P of k minus 1 and P of k minus 2. Now remember, this is a stronger assumption, and therefore, if we do that, we are really doing a proof by strong induction on n. So let me write that at the beginning there. And now we're going to assume that not only P of k is true, but also P of k minus 1 and P of k minus 2. So in this case, notice B is equal to 2. We're going 2 back from P of k. And with this assumption, we're going to have to prove that P of k plus 1 is also true. Now remember that by the inductive hypothesis, this proposition is true, so is this one, and so is that one. So now we're going to use this proposition, which is part of the inductive hypothesis, to infer directly that postage amount of k minus 2 cents can be formed using only 3-cent and 5-cent stamps. And to be more precise, let's say you can do so by using exactly x stamps of this amount and y stamps of this amount. Well, if that's the case, and that's clearly what the hypothesis states, then it's easy to form postage of amount k plus 1. Because to go from k minus 2 to k plus 1, you just have to add 1 3-cent stamp. So we can infer directly that postage of k plus 1 cents can be formed using exactly x plus 1 3-cent stamp, that is 1 more 3-cent stamp than we used here, and y, that is the same amount or number of 5-cent stamps. And this proves that we can form the postage amount of k plus 1 cents. In other words, we just prove P of k plus 1. So, with this very short proof, much easier than in the previous proof, we are done proving the inductive step. Now wait a second, we're not quite done yet. We actually made a couple mistakes, and I hope that you cut those. The problem here is that we started our inductive hypothesis at P of k minus 2. So what that means is B is equal to 2 in this case. So let's record that and then make sure we fix the proof. So if B is equal to 2, then it's probably not correct to assume that k can be any arbitrary value greater than or equal to a, which is 8. So for example, let's take k equals to 9. Now clearly k is greater than or equal to a if it's equal to 9. But here is the problem. We assume P of 9 minus 2 then, which is P of 7. But P of 7 is not true. Notice 7 is less than 8, and there's no way you can form a total of 7 cents using only 3-cent and 5-cent stamps. So the problem here is that k must be not only greater than or equal to a, but actually greater than or equal to a plus b, which is 8 plus 2, or 10. So that was our first error. And our second error, which is related, is that the number of propositions we need to prove now in the basis step is equal to b plus 1, that is 2 plus 1 or 3 propositions. Sure, we have to prove p of 8, but we also need to prove p of 9 and p of 10. So let's do that right away. Can we take 3-cent and 5-cent stamps to total 9 cents? Well, the answer is yes. We just take 3-cent stamps to a total of 9 cents. So p of 9 definitely holds. How about p of 10? Well, in this case, we can use 2 5-cent stamps to total 10 cents. So therefore, p of 10 also holds. Now with these two corrections, we have completed the proof of this theorem by strong induction on n, since we provided a correct proof of the basis step and a correct proof of the inductive step.